Mobile networks give us the power to connect with anyone from almost anywhere. We use smartphones and other devices to make calls, send messages, and access the internet. But have you ever wondered how these networks reach remote areas far from cell towers? The answer lies in the stars with satellite technology. Satellites are like giant mirrors in space. They orbit Earth and reflect signals back down to different locations. Imagine you have a flashlight. If you shine it at a mirror, the light bounces off in a new direction. Satellites work in a similar way, receiving signals from Earth and redirecting them to other satellites or back down to ground stations. These signals carry our voices, data, and everything else that makes mobile communication possible. By using a network of satellites, we can extend the reach of mobile networks to even the most isolated corners of our planet. From the highest mountains to the middle of the ocean, satellite technology keeps us connected. This incredible technology opens up a world of possibilities, allowing us to explore, communicate, and share information like never before. Imagine you want to call a friend who's on a ship in the middle of the ocean. Your phone sends a signal to a nearby cell tower, but the signal can't travel across the vast expanse of water. This is where satellites come in. The signal from your phone is beamed up to a satellite orbiting Earth. This satellite then relays the signal to another satellite in a different part of the sky. Finally, the signal is sent back down to Earth, where it is received by a ground station or a satellite dish on your friend's ship. This process happens incredibly fast, so you don't even notice a delay in your conversation. The satellites act as invisible bridges, connecting people and devices across vast distances. They overcome the limitations of traditional cell towers, which require a complex and expensive infrastructure to operate. Whether you're in a remote village, a disaster-stricken area, or simply enjoying the great outdoors, satellite mobile networks provide a lifeline to the connected world. They ensure that communication remains possible, no matter where you are. Satellite communication relies on a fascinating blend of physics and engineering. At its core is the electromagnetic spectrum, a range of frequencies that carry energy through space. Radio waves, a type of electromagnetic radiation, are particularly well suited for satellite communication. Satellites are equipped with transponders, sophisticated devices that receive radio signals at one frequency and transmit them back to Earth at another frequency. These transponders act like relay stations in space, amplifying and redirecting signals with remarkable precision. To ensure reliable communication, satellites are positioned in carefully calculated orbits around Earth. These orbits are designed to maximize coverage and minimize signal interference. The higher a satellite's orbit, the wider the area it can cover, but the weaker the signal strength. Ground stations, equipped with large antennas, play a crucial role in transmitting and receiving signals from satellites. These stations act as gateways between the satellite network and terrestrial communication infrastructure. Section 4. Reaching for the stars. Benefits of satellite mobile networks. Satellite mobile networks offer a plethora of benefits, extending the reach of communication to every corner of the globe. They provide a vital lifeline for people living in remote or underserved areas, bridging the digital divide and fostering economic growth. In disaster relief efforts, satellite phones and networks play a critical role in coordinating rescue operations and providing vital communication links when traditional infrastructure is compromised. They enable first responders to stay connected, assess damage, and coordinate aid distribution. For industries such as maritime, aviation, and exploration, satellite communication is indispensable. Ships at sea, aircraft in flight, and scientific expeditions in remote locations rely on satellite networks for navigation, communication, and data transfer. Moreover, satellite mobile networks are becoming increasingly important for providing internet access to underserved communities worldwide. They offer a viable alternative to traditional broadband infrastructure, connecting people to the vast resources and opportunities offered by the internet. Section 5. Overcoming the final frontier, challenges and limitations. While satellite mobile networks offer immense potential, they also face certain challenges and limitations. One significant hurdle is latency, the delay between sending and receiving a signal. Since signals have to travel vast distances to and from satellites, latency can be noticeable, especially for real-time applications like video conferencing. Another challenge is bandwidth limitations. Satellites have a fixed amount of bandwidth to handle all the data traffic. As demand for satellite communication grows, ensuring sufficient bandwidth for all users can be challenging, particularly in densely populated areas. Weather conditions can also impact signal quality. Heavy rain, snow or cloud cover can attenuate or even block satellite signals, leading to service disruptions. This is particularly problematic for regions with frequent inclement weather. Cost is another factor that can limit the widespread adoption of satellite mobile networks. Satellite phones, data plans and equipment can be expensive compared to terrestrial options, making them less accessible to price-sensitive consumers. To Section 6, a future intertwined satellite networks and our connected world. As technology advances, satellite mobile networks are poised to play an even greater role in our increasingly interconnected world. The development of low Earth orbit, or LEO, satellite constellations promises to revolutionize satellite communication, offering higher bandwidth, lower latency, and global coverage. These constellations will consist of hundreds or even thousands of small satellites orbiting closer to Earth, reducing signal travel time and enabling near-instantaneous communication. This will open up exciting new possibilities for applications like autonomous vehicles, remote healthcare, and the Internet of Things, or IoT. Furthermore, advancements in satellite technology are making it possible to provide internet connectivity to airplanes, ships, and even moving vehicles. This seamless connectivity will transform industries, enhance passenger experiences, and create new opportunities for innovation. In conclusion, satellite mobile networks have come a long way since their inception. They have evolved from niche technologies to essential components of our global communication infrastructure, connecting us across continents, oceans, and even the vast expanse of space. As technology continues to advance, we can expect even more innovative applications of satellite communication, further shrinking our world and empowering us to achieve greater things together.